Okay. And then what's the multiplicity?
1.
Okay. And then the 0 from the second factor?
1.
And the multiplicity is?
2.
Okay. And the 0 from the third factor?
-1.
And the multiplicity is?
2.
Okay. So we know that, I'll go ahead and just draw this. So if I have, so here I have an x-intercept at -2, and I could have two different pictures. And here I have an x-intercept at 1, and I have a possibility of two different pictures. And over here I have an x-intercept at -1, and I have two possible different pictures. So if my graph has multiplicity of 1, does the graph cross the x-axis, or does it touch without crossing?
Then it crosses.
Right. So here it's going to either look like this or this, right? When the multiplicity is even, I like to think of it as bouncing. I don't know. So you have this and this. Those are two possibilities.
Okay.
And the multiplicity is even again. So it's going to look like one of those two things.
Okay.
So we haven't talked about the very first part of the problem, or the first thing they asked. So f of x, if we want to multiply this whole thing out, you have x plus 2. And then x minus 1 quantity squared is going to be x squared plus some stuff. And then x plus 1 quantity squared, it's also going to be x squared plus some stuff. You with me so far?
Yeah.
Okay. So the first term is going to be x times x squared times x squared plus some stuff. And then when you multiply all that together, you're going to get
5.
Mm-hmm. So you know the degree is odd, and you know that the leading coefficient is positive, right?
Yes.
You see where I'm getting that? And what does that tell you about the end behavior? So what I like to do is I like to think of my favorite type of odd function. My favorite type of odd function is a straight line. So what is the end behavior if I have a straight line that has a positive leading coefficient? What's the leading coefficient called? It has a special name if it's a straight line. For a linear function, the leading coefficient is the slope. If I have y equals 5x plus 2, what is the degree? So your degree is your largest exponent on x. What's the largest exponent on x?
1.
Right. So what's the degree?
1.
Okay, which is odd. And what is the leading coefficient?
5.
Mm-hmm. And that was positive. Is this an increasing line or decreasing line?
Increasing one.
So what does the left arm do?
Left arm falls to the left, and the right arm rises to the right.
Yeah. Any other time you have an odd degree and a positive leading coefficient, it's going to have that same end behavior. Okay, so I would like you to be able to recreate this chart on your test paper. So when we go back to the other problem, so it had an odd degree and it had a positive leading coefficient.
So then it's right rises and left falls.
Right. We had a 0 of -2 that had multiplicity 1. And we had a 0 of 1 that had multiplicity 2. And we had a 0 of -1 that had multiplicity 2. And we know that the left arm is going to fall and the right arm is going to rise. Okay. Then they ask us for the y-intercept. And so we're going to plug in x equals 0 for that one. And so 0 plus 2 times 0 minus 1 squared plus 1 squared. The answer to that is all
2.
right. We had a 0 at -2. We have a y-intercept at +2. We had a 0 at -1 and a 0 at 1. So we start out, we know that it's coming up from the left, right?
Yes.
Okay. And then is it going to cross or bounce at -2?
Cross.
Okay. And so when you put your x-intercept at -2, it's going to give you one of the two icons. And you know that you're going to want the increasing one, not the decreasing one, because you're starting from the bottom. So it's pretty important that you do it from left to right or you get confused. So then to come back and hit the next x-intercept at -1, it's going to cross or bounce.
Bounce.
Okay. And then it looks like it's going to have to come back and hit 2. Is it going to bounce or cross at 1?
It's gonna bounce.
And then does that give us the right end behavior at the end?
Yes, because it falls to the left and rises to the right.
Right.